We have to prove that sin x plus sin 3x plus sin 5x plus sin 7x, all of these add up to 4 cos x, cos 2x, sin 4x. On the left hand side we have the sum, and on the right hand side we have a product. It's a very common type of problem. The strategy here is to consolidate as many terms as possible. We'll try bundling these terms, we'll try pairwise bundling them and see if we can reach the right hand side. Pause the video, try this on your own. Okay, let's do this together. We have sine, sine, sine and sine. So clearly the identity that we can use is sin a plus sin b. That's 2 sin a plus b by 2 cos a minus b by 2. But which signs to pick, which signs to pair? Should we pick x and 3x and 5x and 7x, or should we pick some other combination? The clue here is in the values of the angles. We have 1, 3, 5 and 7 as multiples of x. So 1 plus 7 by 2 is same as 3 plus 5 by 2. So 1 and 7 paired give us 4 and 3 plus 5 paired give us 4. Both of them give us 4. This is a clue that one of these terms, when we add things like this, if we add sin x and sin 7x and then we add sin 3x and sin 5x, whatever the sum is for both of them, one of these terms will definitely match. So this is the clue. We'll add x and 7x and 3x and 5x. So let's pair them. Sin x plus sin 7x plus sin 3x plus sin 5x. So applying sin a plus sin b here, we get 2 sin x plus 7x by 2 cos x minus 7x by 2. And here we get 2 sin 3x plus 5x by 2 cos 3x minus 5x by 2. So let's simplify. X plus 7x is 8x, 8 by 2 is 4, exactly as expected. So this is 2 sin 4x cos 1 minus 7 is minus 6, minus 6 by 2 is minus 3. So cos minus 3x plus 2 sin 3 plus 5 is again 8, 8 by 2 is 4x. So we're getting 2 sin 4x and 2 sin 4x. We also have sin 4x here on the right hand side. So we're probably heading in the right direction. Cos 3x minus 5x is minus 2x by 2 is cos of minus x. Cos has an interesting property. Cos of minus theta is cos of theta. So we can completely ignore the negative sign. We have 2 sin 4x cos 3x plus cos x. 2 sin 4x is taken common. Now we can apply a different identity, cos a plus cos b. Cos a plus cos b is 2 cos a plus b by 2 cos of a minus b by 2. So this becomes 2 sin 4x times 2 cos of 3x plus x by 2 cos of 3x minus x by 2. So this simplifies. This becomes 2 times 2 4 sin 4x cos 3 plus 1 4 by 2 cos 2x. 3 minus x is 2x. 2x by 2 is x. So we have these 3 terms. In fact 4 terms. One of them is 4. We have 4 cos x, cos 2x and sin 4x. On the right hand side we have 4 cos x, cos 2x and sin 4x. Hence proved. Let's take the next one. We have this numerator sin 3x plus sin 5x plus sin 7x plus sin 9x, and we have this denominator cos 3x plus cos 5x plus cos 7x plus cos 9x. This ratio is equal to tan 6x. Pause the video, try proving this. Okay, let's do this together. Again the same question. We're adding sin a plus sin b, but how do we pair them? 3 plus 9 is 12 and 5 plus 7 is 12. So let's pick the first and the last, and then let's pick the middle two. So sin 3x plus sin 9x, this is one pair, plus sin 5x plus sin 7x, this is the second pair. We can do the same thing in the denominator, cos 3x plus cos 9x, one pair, and cos 5x plus cos 7x as the other pair. Now let's use identities. Cos a plus cos b, that's 2 cos a plus b by 2 cos a minus b by 2. And sin a plus sin b is 2 sin a plus b by 2 cos a minus b by 2. In both of these, we get one of the terms as cos of a minus b by 2. So whatever we do, watch out for cos of a minus b by 2. This is probably something that will take out common. Now let's apply the identities. Sin a plus sin b here. We have 2 sin a plus b by 2 cos a minus b by 2 plus 2 sin a plus b by 2 cos of a minus b by 2. In the denominator, we have 2 cos a plus b by 2 cos of a minus b by 2 plus 2 cos a plus b by 2 cos a minus b by 2. In the first one, a and b are 3x and 9x. Second one, 5x and 7x. Same in the denominator, 3x and 9x, and then 5x and 7x. Let's simplify. We have 2 sine 3 plus 9 is 12, 12 by 2 is 6. So this is 3 sine 6x, cos 3 minus 9 is minus 6, by 2 is minus 3, and the negative sign is not important because we're in cos. So cos of 3x plus 2 sine 5 plus 7 is 12, by 2 is 6, which is good for us. Sine 6x here, sine 6x here. Cos of minus 2x by 2, which is cos of minus x, which becomes cos of x. So the numerator is 2 sine 6x cos 3x plus 2 sine 6x cos x. We can take 2 sine 6x common. Let's see the denominator. We have 2 cos 3 plus 9, 12 by 2, 6. So this is cos 6x. Here we have 3 minus 9 minus 6 by 2 minus 3. That becomes plus 3. So 2 cos 6x cos 3x plus 2 cos 5 plus 7, 12 by 2. Again the same thing. 2 cos 6x cos minus 2 by 2. That's cos minus x. That becomes cos x. So let's take 2 sine 6x common in the numerator and 2 cos 6x common in the denominator. 2 cancels out. We have sine 6x and cos 6x. And what's left? We have cos 3x plus cos x in the numerator. But we also have cos 3x plus cos x in the denominator as well. So these two are same, they cancel out. We are left with sine 6x by cos 6x, which is equal to tan 6x. Hence proved. Let's solve one more problem. Sine 3x plus sine 2x minus sine x equals to 4 sine x cos x by 2 cos 3x by 2. This one's a little tricky. Here we don't have 4 terms, we only have 3, and we don't have all positive. We have 1 positive and 1 negative. Pause the video, try this on your own. Okay, so how do we do this? We can have sine a minus sine b. We can take these two terms. Sine a minus sine b is 2 cos a plus b by 2 sine a minus b by 2. So once we do that, we'll have a plus b by 2. That's 2x plus x. That's 3x by 2. Half of 3x. Which means we'll probably later in the proof use sine 2 theta here as well. We'll split 3x into 3x by 2 and 3x by 2. So let's do that. Sine 2x minus sine x, that's equal to 2 cos 2x plus x by 2 sine 2x minus x by 2. 2 cos a plus b by 2 sine a minus b by 2. So this becomes 2 cos 3x by 2 sine x by 2. Now let's look at cos 3x by 2. How can we get cos 3x by 2 from this sine 3x? So sine 3x is sine 2 theta. That's 2 sine theta cos theta. 2 sine 3x by 2 cos 3x by 2. That's how we can split sine 3x. And this term is 2 cos 3x by 2 sine x by 2. And in both of these terms, we can get 2 cos 3x by 2 common. This is also something that we see on the right hand side, cos 3x by 2. So let's take 2 cos 3x by 2 common. We have sine 3x by 2 plus sine x by 2. Here we can use sine a plus sine b. That's 2 sine a plus b by 2 cos a minus b by 2. So this becomes 2 cos 3x by 2 times 2 times sine 3x by 2. That's 1.5x. So 1.5x plus x by 2 is half. That's 0.5x. So a is 1.5x and b is 0.5x. 2 sine a plus b by 2 cos a minus b by 2. So this becomes 2 times 2, 4. Cos 3x by 2 is here. This becomes sine of 1.5 plus 0.5 is 2. 2 by 2 is 1. So sine of x. Cos of 1.5 minus 0.5 is 1. 1 by 2 is half. So this becomes cos of x by 2. So these are our terms. 4 sine x, cos x by 2 and cos 3x by 2. 4 sine x, cos x by 2 and cos 3x by 2.